I'm Benoit Montreuil. Welcome. We're really pleased to have you here today. We've got a smaller crowd than normal because there was a big conflict with the masters and supply chain engineering students who normally come to such seminars. We have the cream of the crop today. So it doesn't have quantity, you got quality here, so that's really nice. And I'm very pleased to have Dr. Jennifer Pazur with us. She did her PhD in Arkansas with a good friend of mine, Ross Meller, who's been very well known in academia and now in this industry. And Jennifer has more and more made a name for herself, with very innovative research around first facilities design and now much more into the supply chain spectrum. So she's been quite active, both academically and with industry, which I like very much. At her academic age, she's doing great stuff on those lines. Very curious and very broad scope type of ideas. NSF has recognized this and gave her recently a career award, Young Investigator Career Award. So this is really nice at this stage. Some people here have gotten that in their youth, and that's very appreciated. And I like also the kind of research she's doing, which is very near to our art in the Physical Internet Center and more broadly in the Supply Chain Logistics Institute. I won't get into repeating her title, but so it's a mixture of research that has part conceptual contributions, but then also much more technical facets of it. So I'll leave Jennifer with you. Oh, by the way, before she studied in Arkansas. She was assistant professor Central Florida, and now she's at Rensselaer. So since now a year.
Almost 3 years.
Almost, yeah. So I typed fast, too fast. So the floor is yours.
Okay. Awesome. Well, thank you. I'm genuinely excited to be here, and I appreciate you spending your lunchtime with me. And thank you, Benoit, for inviting me today. So my idea today to talk about is I want to spend the beginning of my lecture to really motivate why I think we need to rethink supply chain design. And then I have one example of how I think we can do that. There are many of them, and many of them I spent this morning talking with Benoit about things he's doing that are very much in line with that. And then ultimately, really thinking this is the beginning of hopefully a long journey. And so there's definitely lots of future research very specific to what I'm talking about. But also I'm hoping that there's some discussion about what are ideas to build on this. To get started, I want to kind of ask you a bunch of questions. So how many of you have purchased something online in the last week? Is anyone? All right. What types of stuff have you purchased? Anyone willing to say what they've purchased? Shoes, okay. Diapers.
Dog bowls.
What'd you have?
Dog bowl.
Dog bowls, okay. Any other bizarre things that anyone's willing to say?
Dinosaur.
A dinosaur, okay. So I would say that's quite a wide assortment from a dinosaur to clothes, right? How long were you willing to wait to get these items? Were you willing to wait a week? Okay, a little bit. Couple days? All right, anyone demand like 1 hour delivery?
I want my dog bowl now.
Yeah, now, okay. And where did you get that delivered to? Likely your house, probably, right? And were you ordering a full pallet of those things, or did you just order a pallet of dog bones, or just like a couple, right? And how much were you willing to pay for these? Were you willing to pay a lot for shipping? So the surveys say no, so that there's not much there. So you've really contributed to what I would say is a fundamental change in how we need to think about supply chains. So today's customers expect a wide variety of requests to be fulfilled extremely quickly with very little warning. You didn't forewarn what we need to do in small units, so at the piece level instead of the pallet level, and to many dispersed locations. So we're going to your houses instead of willing to come to your store, and at extremely low cost, okay? So this is today's customer expectations which I will say is fundamentally different than yesterday. So yesterday we were willing to have fixed store locations, and the demand would aggregate at those locations. And so my hypothesis is that today's supply chains are optimized for yesterday's customers. And so when you think about what worked really well yesterday, we had very fixed networks. And so we thought about, let's optimize where should we locate those different locations. And then once we have those locations, how should we optimize the resources that we own? And a lot of those resources are big things, and we could even think innovatively about that in terms of, Walmart got famous about doing cross-docking and things like that. But it was all built around the fact that I knew where my demand was happening. It was very fixed, and we had aggregate demand at those locations. And that's what worked well in the past. My hypothesis is that's not going to work well in the future. And you don't have to take my word for it. These are all companies that have either filed for bankruptcy or have closed major numbers of stores in the last 6 months. And this is by no means an exhaustive list. And I think there's a really interesting survey that came out recently that found that only 10% of global, so this is not just the US problem, global brick and mortar retailers are actually profitably fulfilling e-commerce orders. So to dissect that, that means if I'm in a Macy's or a Gap that has physical stores, and now I also have another channel, the online channel, if they're using the same supply chain network and using the same decision making and kind of optimization approaches, they're not doing well. So 90% of them are actually not affordably making money. So that brings me to the idea that we really need to rethink supply chain and logistic design. And I think there's two really big categories we can rethink supply chain design. We can rethink supply resources. So what do we mean by a network? What do we mean by resources to fulfill the customer requests? And we can also rethink how these demand requests are going to occur. I am of the belief that our now, and we want this fast is not going to go away, but we can be innovative about how we deliver that. And so today I'm going to talk about rethinking supply resources, but I think there's other things you can do in kind of both of these spaces. The best way I think to think about this is through a picture. So here is a picture of Seattle, downtown. And do you think there's extra capacity on that road? Do you think you could move more people or goods on that roadway? Any ideas? Any thoughts? Is it full? Any creative ideas of how I could move more people or goods through that road? Sidewalks? So yeah, we could use the sidewalk. Sometimes when I give this, you could say maybe we have a biker in there. Any other thoughts?
Put them in buses.
Put them in buses, okay. Vertical, right? You could have some hover, drones, something going on, right? Crowd shipping.
How
So
about
you,
you put 4 people in a car?
all right, so this is the same picture, only without the cars, okay? So it's very clear there's all kinds of capacity. There's all kinds of extra capacity in this picture. However, we can't think of capacity the traditional way we've thought of capacity in the past. We can't think about adding more cars. Instead, we need to think about how can we tap into inside of that car at a smaller granularity, how can we tap into all of this extra capacity? And so I call that underutilized capacity. These people are going there anyways. Can we somehow tap into that? The other thing about capacity is we need to not think about it in terms of ownership. So we need to think about if we really want to tap into this, it's not that I own that person's trunk, so we need to operationalize a little bit more what we think about capacity, okay? So this picture is kind of at the heart of my motivation for a lot of my research, is I'm interested in tapping into these underutilized resources on demand, and I feel that is a potential way to get away from this static fixed network and have a much more dynamic, elastic network. Okay, and there's a ton of analogies to supply chains to my car picture. One example is a warehouse or a distribution center. These, by definition, are extremely static resources. So once you build that, it's really hard to kind of make it go up or down. However, this is commonly what demand looks like or inventory looks like. And so if you're building a static fixed resource, to fulfill something that looks like this, there's a mismatch. So there's either underutilized resources. So if I build at the blue, I have underutilized resources. Or if I could think about somehow making my resources less fixed and static, that would be good. Okay? And I actually have a project going on right now that I'm not going to talk about in tons of detail today, looking at this from a facility location perspective, and looking at how can we build a dynamic and elastic resource network. Flex is just an example of this. They're really an on-demand platform, kind of Airbnb for warehousing. And our interest here is in more the facility location problem and how do you get access to scale, how do you compete with Amazon without owning the number of distribution centers that Amazon does. But today I'm going to talk kind of more generally about a different type of on-demand platform. So Flex is an example of that. The two most common on-demand platforms that you've probably heard of are Uber and Airbnb. So the idea here is that there's a central mechanism or a platform that owns no resources. So Uber owns no cars, Airbnb owns no facilities, hotels. Instead, their value is in, first of all, tapping into underutilized resources and matching that with demand on demand. So in other words, you click a button if you want to say, I want Uber, and it finds that matching. And so their value is really in that matching of supply and demand. And they're interested in kind of a systematic perspective. So they want the maximum number of people to participate in this platform. And they also want people to participate continuously. So I want to use this service over and over again. So who actually owns the resources? They're what I'm calling agents. So they are, if you're using Airbnb, you're the owner of that house that you're renting out. And so because nobody owns me, the platform doesn't own me, my hypothesis is that we need to make sure we're providing discretion and autonomy to these agents. And these agents really have an individual perspective. They own the resource, and so I'm going to provide access to that, but I own that. So I have preference for that. And so there's lots of different players in this space. A few kind of in the supply chain realm are on the bottom. But I would say what I'm really interested in is how can we design these systems and how can we operate these systems in such a way that we tap into existing underutilized capacity on demand. So I'm going back to my car picture. I'm interested in underutilized resources and how to tap into them. So I could make the case that Uber is a different type of capacity, but I don't know if they're necessarily tapping into underutilized capacity. They're creating different types of taxi drivers, but it's not that they were going there anyway. So I would say that's a little bit different of what I'm interested in is if I'm going from point A to point B and I have extra capacity, can I tap into that? Any questions, comments?
But isn't that always the case, that if you create a platform like this, you will create an avenue for people to do this, right? And so it's you might think initially that you would start with a system in which, I'm driving there and I'm going to give people a ride, and it just turns into, I'm going to be an Uber driver.
Sure, yeah. So I'm not saying, I would agree that potentially, I'm not preventing us from creating extra, but I want to have this in mind when I'm designing, and some of my algorithms that I'll talk about, this is at the heart. Because I am actually very for providing someone a ride if you're going where I'm going, but I don't necessarily want to be an Uber driver on my spare time, that kind of thing. So that's where I would say my focus is. Yes, probably you will attract people that are participating in the platform beyond that. Any other questions or comments? All right, so let me talk about how this would work kind of operationally. So please meet Millennial Millie, okay? So she gets off of work and she gets a text message and it asks her, would you like to deliver groceries to others in the community? And she's a good millennial, she wants to make a difference, so she clicks yes, okay? And then at that point, there are two choices that appear, okay? So to who? Would you like to deliver to Jane, who lives near Millie's home? Or would you like to deliver to Will, who lives downtown, okay? And she actually has plans to go downtown to meet a friend. And so she's going to select Will. And she's going to then get notifications on her smartphone about where to go pick up these if it's a nonprofit, and then make the deliveries. Or this could be a commercial setting where you're getting groceries at your local grocery store, and I'm a member of kind of this rewards card, and so when I check out, I say scan this, and they could see, oh, you also have these options. Would you be willing to do the last mile delivery in a kind of ad hoc or crowdsourced way? So this could work for either kind of a nonprofit setting or a commercial setting. But let's dissect kind of what's happening here. Okay, so first of all, we are able to tap into Millie's underutilized capacity as needed, results in resource elasticity. So what I mean by that is, if I didn't need someone to make that delivery, I wouldn't tap into her. And this allows my resources to be less static and more dynamic, both from a spatial perspective as well as a temporal or time perspective. So that's great. But to do that, I really need to entice Millie to do this. So I am not controlling her. She could say no. She could have selected neither Jane nor Will. And really the platform, so who's sending these messages, they don't have control over her, so they can't force her to do this. She's not an employee of this platform. And they also don't have perfect knowledge of what she's doing. So most of the night, she probably would go home, and therefore, if they only recommended Will, she would have said no, and she wouldn't have participated, okay? And so I provide choice, or the platform provides choices. They're definitely estimated based on some past history, but they don't have perfect knowledge about that. And so choices, so that's good, but choices also have consequences. So what happens to Jane? You know, they need their groceries too. Who's gonna cover that? That would be a reject. And because I'm providing choice to someone that participates on this platform, that means that they could say no. And so to hedge against the people saying no, you might wanna recommend multiple people the same request. And so what happens if both people pick this? I only need to make one delivery. There are consequences. There are others, but these are the two kind of major ones. And then if you dissect this, if you think about it from kind of a decision-making perspective, there are actually a lot of decisions required to make this operation happen. What choices? Why did I recommend Jane and Will? How many of them? Should I have recommended more of them? What if I compensate? What if the platform, meaning, you know, if it's a grocery store, they likely have some of their own delivery capabilities? So how do I use that and tap into that? But there's trade-offs. If I wait too long, then I'm really have short time windows, and you know, how does that all work? And many, many more. So this is really at the heart of my research, is to try to think about, I want to tap into underutilized resources on demand. I want to provide choices to multiple agents, which are kind of thought of as ad hoc suppliers. But I also need to balance that I need to make sure these demand commitments get made, okay? So that's the central challenge of a lot of my research. Yeah.
I want to come back to something Alejandro said, and partly just asking your opinion, right? So ride-sharing apps and platforms have been around for 15 years at least.
Yep.
It never really took off and worked until Uber took over, and in a way changed the model from the one person that sometimes goes to work and says, I'm happy to take somebody, to actually having people that almost do this as a job. Right?
Yep.
I ask them often, how many hours do you do this? And most of them don't do it just for 5 minutes.
Yeah.
Or they do it for several hours and sometimes every day.
Yep.
So it still sounds that you would like this to be more on an ad hoc basis for individuals. How do you think that's going to happen, right? Past experience isn't very encouraging.
Yep. No, I agree. So past experience, but I would say the difference here is technology and the reach of visibility. So sharing has started from very beginning of humanity. We shared, but we only shared with people I knew, right? So I shared, you know, I know you, so I'll share my resource, you know, this kind of thing. Now, all of a sudden, you have much more reach into who wants a ride, and potentially it could be a little bit better tied together, both spatial and temporally, potentially.
Yeah, but that was already true for the people that try to do ride sharing with individuals that only go twice a day for a reasonably short distance, right? So the technology was already out there.
Yeah.
but only when Uber did it in a slightly different way, it started to work. So I'm still worried that, I personally would like it much better if it's really individuals and we're not exploiting drivers and don't pay them, etc. I just sort of, I don't fully see how we can go from one to the other.
Well, so I think Uber has also helped this. So I think in the past it didn't work. Now, when I first started talking about this, I had to explain what Uber was, and people were like, I wouldn't get in a car with somebody else. Now that's just second nature. So I also think if we retry this experiment, we're not at the same point as we were initially. But you're right, there's lots of potentially problems.
Quick question. I'm only mentioning this because I'm looking at your emphasis on demand.
Yep.
So in the beginning, you mentioned that, or the implication that I got from it was that the reason why some of those companies declined was because they're not using innovative processes and so on and so forth. How do you know that this may be the solution? And the reason why I say that is for, let's say, Toys R Us. Right?
Yep.
Is in the financial community, they feel that they just were overloaded like debt. With Sears and with Kmart and Toys R Us, and a lot of their debt payments that could have went to innovating went to just paying off the debt. Yep. Zara seems to be doing quite well. Their fixed locations. The only difference is, from what I understand, is they collapsed their supply chain so that they can enhance their cycles. So this really goes back. Not to say that you're not in bad company, because Travis Hyman from Uber is getting into this space. I'm just saying, how can you know for certain, or the threshold of this is why? I'm fairly certain that the reason why they're not doing well is because they're not doing this.
So I would say, first of all, it's much more complex than just the delivery. But I do think fundamentally, demand has changed. So fundamentally, we are not going to physical stores anymore. We're getting stuff delivered. And I think what's telling is the statistic that they did a survey of a bunch of retailers, and you take a given retailer, and it's not saying they're not making a profit, but they're not making a profit on their e-commerce side. So that JDA survey, they surveyed a bunch of different retailers, and some of them could be doing really well financially, but they are actually losing money currently on their e-commerce operations. And so they might still be around for a really long time, but I would say they need to think differently about how they fulfill e-commerce demand than how they fill store demand. Does that answer?
That's good.
Of course, Amazon lost money for the first 20 years
Exactly.
of their operations too, right?
Yes.
They still don't really make money. They just plow it back into something.
Yeah. So, great question. All right, so that was an example of just like one person. Let's kind of, bring this out a little bit more abstractly, and if you have multiple agents examples. So here I have, 3 Millies, right, different agents. And we also have some preference. We know some preference about these alternatives. And just to make it easy, we have a capacity of 1. So each agent can fulfill one and only one request, and each alternative only needs 1 agent to fulfill it, just to make life simple. So the traditional you have agents and alternatives. You could think, okay, let's use the Hungarian method, just very centralized optimization. I care about how do these alternatives get matched with the agents, and we ignore anything about the preferences, but we basically have a dictatorship. So if we did that, we could say, okay, based on different utilities of the system, you could say, I'm going to assign this this way. But here, one thing I want to note, the N is the no choice. So at some point, they have a threshold. Maybe they're only willing to drive so far out of the way if you go to my rider or driver situation. And so there is this no choice where if you offer me A or B, I'm just not going to participate. And so the centralized systems are really not applicable in this kind of ad hoc purpose, because you can end up, I recommended 3 to B, and they didn't select it. Okay? You could say, okay, well, we really care about the The agent. So I'm going to provide every alternative to every agent. So that's a very decentralized approach. So agent 1 can see A, B, and C. Agent 2 can see A, B, and C, and so forth. The problem there is we have myopic decision making. So the price of anarchy types happening. And so here you have 2 and 3 both wanting this one request. And then B, nobody picks. Okay?
Can I ask one more question about your centralized system?
Mm-hmm.
It looked to me like the issue was not the fact that it was a dictatorship, but the fact that the dictator didn't have all the information.
Yes,
Is
and
that true, or is there a difference?
there is a difference in the sense, this is a very important part of which I explore, is what is the value of how much information they have. But the one thing here is, I should probably add this to my slide, is they have utilities here. So thinking about how Uber traditionally did it, they just cared about the wait time of the rider. So that may be a different utility than the agents, which maybe want to end up close to their destination. So what I'm using for the centralized system, even if you assume they know everything about what's happening, then you could do this, and if you know exactly even the no choice, you can assign them things such that they don't pick no choice. So there is some aspects of information, and I will actually detail more of that as I go along. But one of the issues with centralized systems is if they truly are kind of the very simplified version, is all I care about is my platform, totally ignoring everything else, that's probably not a good idea because you have to entice these people to participate. But we'll get back to yes, information about how they can estimate what the agents are doing becomes really crucial. So this is obviously a very simplified example, but so what I'm proposing is a much more integrated or hierarchical approach, which tries to combine these two benefits. So the good thing about centralized is it's able to take a systematic perspective so that you don't get myopic behavior. Not two people are picking the same one, or you're trying to kind of prevent that. On the flip side, we like decentralized in the sense that you take into account that these have utilities and they have agency and we want to provide them. So the idea here is, what if we could personalize my recommendation? So number 1 gets showed all of them, but 2 only gets showed A and B, and 3 just gets showed C, for example. And in that case, in this very simple example, then each one of them are getting picked. And so they're all better than the no choice. There might not be their first choice, but they are willing to participate in my platform.
So that's kind of like a stable marriage problem?
Similar, except stable marriage cares about, do I really care about my first choice and if somebody else's? So I would say we care more about, are you willing to participate? It might not be the best utility for the agent. It's similar to stable marriage, but not exactly. So stable marriage, and we'll show, I have actually compared our results to that, in some ways prioritize the agents a little too much, and you could reduce your systematic performance. But there's similarities to this, and I actually will compare ours to a stable matching problem. Other questions, comments? Okay, so that brings us to kind of a ton of research questions. To very much joint work with my PhD student, Shab Mofidi. So when I think about how do I design this system that I really want to tap into ad hoc suppliers, is we think about, well, what alternatives should a platform recommend to multiple agents simultaneously given this finite resource capacity? How can we develop a new hierarchical method to balance the need for demand commitments and choice? What is the performance of this compared to these kind of more traditional approaches? And then one thing that's really at the heart of what I think is exciting and kind of as a proof of concept is understanding choice in these systems, okay? And so menu size, or how many choices I should give to someone, I think is an interesting kind of central driving a lot of the development of these models. So the current set of the knowledge, so in terms of resource sharing platforms, there is a definitely growing set of research in this area. So it started with more descriptive, econometric, but there are definitely prescriptive models thinking about how can we develop resource sharing systems. More specifically, in terms of dynamic ride-sharing, crowdsourced delivery, there is actually a growing population of literature with some of the authors in the room. And if you think about these approaches, you can put them in two kind of broad categories. Centralized approaches, and I don't mean just the Hungarian method, more complicated than that. There are kind of two ways to think about it. There are some papers that say, I want my suppliers to have preferences, but you have to bid a day in advance, so it's not on demand. And then they take into account these preferences and these bids, but there's a lag or there's some latency. And then there are ones that take a centralized optimization to match supply and demand. And they are motivated, I would say, by similar ideas that I'm motivated by, but they use constraints to enforce that. So you may say, I'm only going to have a max detour distance. So I add a constraint to my optimization model, or a number of stops, or you want to enforce that there's, this is a stable match when it's being made. There's also a paper that fits really well with what I'm doing that's getting older from Powell that had nothing to do with resource sharing, but they're interested in accepting, rejecting, and doing some dispatching that actually has a lot of similarities. The difference here is they have a single dispatcher. They don't care as much about the multiple agents. And there's also decentralized approaches. This is just one of them. There's actually many literature there. So the gap in terms of this, specifically on-demand distribution platforms, is no one's really looked at the hierarchical approaches to this process. So looking at that there is a central decision maker that makes maybe recommendations, but there's also a decision being made by these suppliers. And so that's where our research is contributing to this body of literature. And you can say, well, there's been a lot of literature in bi-level optimization. We're by far not the first one to do that. Assortment optimization from traditional network design. So you design a road and then people decide how to travel on that road. Those are all bi-level hierarchical literature. But existing work typically fits into two of these things. You have either, the probably most common is this one. You decide your assortment. So think about a traditional store. What is put on those shelves? You decide it once. And then individual shoppers go, but they all have the same assortment. Similar to a road network. You design a road once, and then yes, there's individuals that make decisions, but you don't have a personalized road for each person, right? So a lot of the bi-level work is actually one aggregate decision followed by everyone sharing that. There's also work that looks at, okay, I'm going to give you an independent decision, but there's no interaction between them. Versus the stuff that we're looking at is that we are interested in making personalized recommendations to multiple agents, but it matters not just the decisions that I send from my platform, it also matters if you select the same one as this person selects the same one, there's interaction, okay? What we really care about is we want to prevent rejections. We basically want to make sure that we serve these requests. And so it is okay if you say no as long as he says yes, right? And so there's interaction between this. So the agents' selections are interdependent that influences the performance of our system.
Can you do this, let's say, in a one-round mechanism?
Oh, sorry?
One-round mechanism?
So
Then you have to have a way to deal with the fact that if you offer something to two suppliers, they may both accept, right?
Yep.
So there has to be some mechanism to deal with that.
Yes.
And are you then simply assuming you assign it to one of them?
Yeah,
Or
so
is there more coming?
Yeah, so the stuff I'm presenting today, I'm assuming a snapshot, but that's definitely future research, is that, okay, if you have a duplicate, I just right now have a tiebreaker that says, okay, which one gets this? But you can have this in a very dynamic setting in that you would say that then starts back as a request, and that is the future work of this, definitely. So right now, I assume there's one round, and we deal with the consequences of that round based on some rule. But future research is to make
Because
that.
there's a lot of psychology there.
Yeah.
Right? I mean, if I do put in a bid to get something and I get turned down a lot,
then I won't participate in the future. Exactly. So, and I think that part to me is really interesting, is how do you make sure that this is viable system? And in some ways, I'm trying to encourage participation as much as anything. And the participation is two-sided. If I want to participate and no one's there, that's not good. And if I have people there and no one wants to participate, that's also not good. So this is really what I'm interested in, is trying to understand how can I engage participation through this idea of choice. So to give you a framework, on the x-axis is the number of choices. So in my example, I gave 2 choices. I gave Will and Jane. But you could think about more choices. And so what I think would be interesting is this black line. Okay, so initially this is just kind of hypothesized. If I only give you 1 choice and the platform is not exactly sure what I'm going to do. So they have some information about you, but there's error in that estimation. If I only give you 1 choice, there's a high chance that's a choice I don't want, and I reject it. So if I give you another choice, there's a higher chance that I would actually accept something. However, that only works up to a point because you lose performance, and the y-axis here is the platform's objective or the system's objective, because I'm willing to maybe give you one that you want, but the platform really wants you to take another one that you don't take. Also, at some point, you get this aspect of you're offering them to everybody, and then you get that you have a lot of duplicates and you have myopic decision making. So I'm really interested in this like black curve as kind of a proof of concept. First of all, is there kind of an optimal number of choices? What influences this? Does this increase participation? And then comparing it to kind of centralized, decentralized solutions, and seeing what happens. Does that make sense, kind of what's going on? All right, so kind of when resources are finite for this example, and we'll see this with some of our preliminary results, is the centralized solution gives you only 1, and then if it's not the one you want, then you reject it. Some of them will pick it. The decentralized one gives you all 10, but everyone sees all 10, and therefore it can be myopic. So can we do better than those 2 systems? Dictatorship here is an upper bound in the sense it might not be achievable, in the sense that I just care about what's the best for the system, assuming I can force you to actually do that, which is why it's an upper bound for our model.
Just looking at the number of choices, I can't think of a situation that you offer extremely bad choices to everybody. And so my question is basically, is it really the number of choices or it's the quality of the choices?
Yeah, so inside of here, I'm also caring about which choices. So I care about which ones as well as how many. Okay. And so if you count which ones, count them, that's how many. So I am definitely interested in both, and our method actually optimizes which ones. But kind of as a more fundamental research question, I think this is interesting. But yes, I'm optimizing which ones as well. So our very kind of preliminary model is a bi-level optimization framework. It's also a Stackelberg leader-follower game. So the leader makes Xij decisions, which are binary, that says, I'm going to recommend you this option. And there are different constraints here, and we can add more. But the one thing I want to emphasize is in the objective function, these Zi and Wi are rejections and duplicates at this moment. So the performance is influenced by what a bunch of people select. And the lower level, so you can think about it network-wise, the X's are kind of showing what am I showing to the agents. And then the agents respond on the second level. They are only able to select something that was actually recommended. And we assume they maximize the utility of their selection, but their utility, Uij, could be different than the system's utility, Cij, which I'll explain in a few other slides. This is definitely a first step model. Some major assumptions with all of these being planned to be relaxed is we are taking a snapshot view, so we assume we have a set of available requests and a set of available agents. We are only caring about one-sided autonomy right now, so requests will take any delivery from any supplier. So suppliers are the only ones that have autonomy. And here we are assuming these UIJs, the platform can fully understand and estimate, which is a major assumption that we relax in the future slides. Okay. All right, so one thing is, typical, this is a discrete bi-level optimization program known to be extremely computationally expensive. And so I'll show you a graph, it is. The short level is it is. So what we do is we transform this bi-level optimization model into a single-level optimization model using logical statements. So if we know the preference profile of an agent, so this agent prefers 1 over 2 over 3 and so forth, then we can write statements that say, if I recommend you 1, then you would select 1, because it's the one you want the most. We're assuming they're picking the best one. If I don't recommend you 1, but I recommend you 2, you would select 2. If I recommend you 2 and 3, you would pick 2. You know, you could think about, there's all these combinations. There is exponentially many of them, but you can write them all out. If-then statements are obviously not linear constraints, but you can introduce a new decision variable, Tij, which is a binary decision variable, and then you can see there's coefficients will either be +1, -1, or 0. And so you can take this for every supplier. You can then create these constraints. And so that allows us to, instead of having a bi-level optimization approach, we have a single level, and we've taken out the objective function and then built in the constraints. Okay, and so the performance of this, the red line is using KKT conditions. The purple line is what I just showed you. And then, so it's definitely an improvement. We are able to solve much bigger problem sizes much more quickly. However, you know, in an on-demand system, we need to be fast. And so because of time, I won't explain, but the green line is a heuristic approach that we're still working on, but we're getting some promising results of a much faster recommendation and comparing that. The main idea is, can we somehow project the two UIJs and CIJs, the alignment between the system and the user, and can we use that to solve a problem there? So we're getting some promising results there, but due to time, I'm not going to talk about our heuristic. So we now basically have a model that we're able to use to kind of get at some insights. And to me, that's what is exciting about research, is I find that the model is useful to get insights into the real system. The other things we input is we input CIJs and UIJs. CIJs are the platform's benefit of making this match, and UIJs is the agent's benefit of making that match. This is definitely ongoing work, but we can think about a data model that you would have information because people are participating in your platform. You would know the current location. You would have some predicted destinations of where this person is going. They're going home, they're going downtown, those types of things. They're definitely predicted in some probabilities. You could have some past history rating and some other character sets. For each arriving request, you would know their origin, their destination, some time window, and other characteristic information. And you can see something like this, and you can start estimating using the data, CIJs and UIJs. The main thing I want to point out is the stuff in yellow are things that you're going to estimate using the data from the platform, but there's still some error term. You're not going to be sure exactly what these people are doing. And so we are currently working on, there's California travel data sets available and trying to use them to kind of start estimating some of this from real data that's available. But from our perspective today, think about this yellow as some number that the platform's able to estimate plus some error term. And so I actually made it even simpler. So we actually ran an optimization simulation setup using our data, or using our model. And the idea here is we randomly generated OD pairs. And then what we care about the platform is we're just simplified. We care about how long does this rider have to wait. So we care about what time where the driver is now, how long does it take to get to them. So that's what we're going to use as the platform's benefit of making a match. The driver's benefit is how much do they need to detour after I drop them off. So if this person is going there, but they really need to end up here, that's the minimum of that distance. Okay? But the one thing to realize is the platform has a really good understanding of what the rider is doing because they put in their origin and destination. But the driver, remember, we're trying to entice them to participate. I don't tell them exactly my plans for the evening. So there is some error term. And so here, we thought they were going to go here, but their destination is actually here. So using kind of a random utility model framework, the red part is the actual utility of that person. The blue part is what the platform estimated that user was going to do. The other thing that's important is, remember, we're trying to entice participation. So the way we put this in there is we said there is some threshold that I'm willing to go out of the way. The platform can estimate that, but there's also an error. And if the distance there is larger than that threshold, I'm not going to participate. So if you recommend me something and it's longer than that, I'm going to leave the system without participating. All right, so to do that, we ran this optimization simulation setup. I know there's a lot of information here, but we basically generate origin, destination, and we have some other input values. And then the optimization engine, we test 4 different types. So we test our bi-level optimization formula I just showed you. We test a Hungarian method that only uses CIJ, so ignores that there's agents and they have utilities. We have a decentralized, which really isn't optimization. We just show everything to everyone. And then we also do many-to-many stable matching. And so we do all K to K choices. So K of 1 is 1-to-1 stable matching. All the way here, we're doing up to 10. Okay? So that's what's going on in the green part. So out of the green part, we run 4 different ways of doing this. And out of it, we basically get a recommendation set. So we get a set of things we recommend to people. And then what we do is we actually simulate what are people actually going to pick. And we're using a maximize utility. So the part that's simulation is really simple, but we're just generating these errors and then saying what are they actually picking, not what did the system think they were going to pick, and then get the actual performance out of that. Does that make sense? All right, so I won't go through all the details, but we do a full factorial analysis. We think about different correlation potentially with riders and drivers, destinations, and origins, different penalties, and different error rates. And here's some preliminary results. Probably like anyone, my grad students gave me these last night, so they're definitely preliminary. And the legend is incorrect, but let's walk through. So the lines that are solid are the ones that are coming out of the optimization, and we haven't done the simulation. So you could think of those as, if I had perfect knowledge about exactly what everyone did, those are the solid lines. And the red is the centralized system. The blue is the stable matching. And the reason it goes off like this is because at K to K, we assume you can make K choices. But then in the simulation, we enforce that you only can make 1. So that's why it does this weird up. The green line is our model, and so the green line is our model. We are maximizing, so we want a big number. And then the dotted lines are what comes out of the simulation. So we are actually simulating choice. So one thing to think here is the red line, centralized, does really well if we know exactly what the person is going to do. That would make sense to do that. The minute the platform is not able to perfectly estimate what these agents are doing, then all of a sudden, which is the dotted lines, all of a sudden our model does better. So if you look at this one, this has low error. This is the same instance with high error. So the number of choices that's best for ours is 1 over here. So the green is the biggest. Here, it's around 6. The green, where's the biggest line here? If you measure the best here, the green versus stable matching, this one is pretty close. The green is a little bit better, but not by much. So in this instance, stable matching approach would do really well. This one, the green is way better than either of those two. Okay. The other things that we thought were interesting, so there are around 3,000 different instances. And so what we did is, out of our integrated approach, when does it make sense to provide choice? And so a large portion of them, it doesn't make sense to provide choice, even in our integrated model. And a large portion of them say, OK, give a decentralized approach. But if you sum up everything between 2 and 9, that's 43% of the instances. So this is kind of a proof of concept to me to say that there is some value in trying to understand choice in these systems, and they could potentially improve the platform's performance. And then we ran a number of ANOVAs. Here, the dependent variable is the platform's objective function. So we were trying to understand what influences the platform's objective. And all factors factors are significant, but what's interesting is the things that really matter. So these are ways to think about if I'm going to design a platform system, what do I need to think about? So what we found is that the threshold of no choice has a huge influence, and that should make sense. If you're kind of willing to do anything, if I show you an alternative that's not the best for you, but it's the best for the system, I'll take it anyways. But if you're really picky, then I really need to be careful about how I'm making these recommendations and how many. Estimation errors definitely play a big role. And then if you really care about making sure you have participation, so rejection is what you care about, then that's also the most important. If you don't care about rejection and you just have plenty of people participating, then just do Uber's model of basically dictatorship. And I have, I think, just one or two more slides. So this is looking at the performance gap. So here's the integrated model objective function versus stable matching, and the integrated versus the centralized approach. Some preliminary insights is that this performance gap is also influenced by all of our factors. But what I think is really interesting is what influences those. So the stable matching, if you're going to do that, you better be really good at estimating utilities. And that should make sense. If I'm going to recommend something to you that you feel is stable, you're not willing to change, you better make sure you know what those are. Versus a centralized approach, what is interesting is your detour threshold is really the most important. So if you're willing to participate versus not, if you're willing to participate and you have a huge threshold, detour threshold, then just use a centralized approach. But if that is more sensitive, then it makes sense to use a more integrated approach. All right, so in terms of contributions and preliminary insights, we created a new hierarchical approach to really look at the supplier choice. So that's what I'm very much interested in. And then we transformed it from a math programming perspective and illustrated performance improvement. And I really, what I view this is a proof of concept that I think providing choice to agents can improve a platform's objective. And the value of choice increases as these different things happen. I will say proof of concept is important here because in terms of future research, this is basically what my NSF career said, was what I just presented to you was basically preliminary insights. And then future research is expanding upon many, many more ideas. So from a recommendation module, the most obvious thing is I'm doing a deterministic optimization and then simulating the utilities, put that into the optimization. In terms of compensation, I think there's some interesting things is how can we influence suppliers' utilities? So if there's one that's way out in the boonies no one wants, is there ways to personalize that incentive? So that is something I'm interested in. Oftentimes, if you really care about making sure that the demand gets fulfilled, you likely will also have some sort of resource that is owned by the platform. And so where are the trade-offs with that? And then there's all the stuff with dynamic models. So when and how to update decisions. So obviously, you have dynamically arriving requests, but there's also things that I think are super interesting about how do you generate trust in this network, and how do you update the information once a supplier is done? How do I update both? Should I have them participate again? And second of all, how do I update their view of them from the platform? So all my data needs to be updated. And can I be smart about what I recommend such that I get good data to then estimate my utilities in a really good way, which we're finding is, preliminary results is a really important thing if you want to get good performance. And then in terms of evaluation, I'm interested in kind of what I'm calling the 3 E's, efficiency, effectiveness, and equity. And one reason for that is one of my use cases is thinking about how do we make deliveries to nonprofits. So this is a map put out by the USDA of people living in what they call a food desert, which is defined here as having no car and then no supermarket within a mile. And so if you think about right now, there are definitely people trying to solve this problem. Things like Meals on Wheels, Radix is a local nonprofit, but when you talk to them, they say, okay, I'm glad to get your volunteer support, but you have to show up every Monday morning. And every Monday, then you make those deliveries. So that's obviously limiting the supply capacity that is available. So thinking about the millennial generation, can we create a more on-demand volunteer base where you want to help, but you want to help on your own terms? And so I think that's something that's also very exciting from a nonprofit perspective. So with that, I think we need to rethink supply chain design. I think there's lots of interesting things happening. I put this up here is that I'm very interested in new mathematical models and algorithms to evaluate new systems and processes to get ultimately insights. And that's my presentation. I would love any questions, concerns, comments, now or offline, that you have. So.
We have time for a couple questions. Anybody has burning questions or comments? All done. There were many questions through the presentation. So Jennifer is going to be with us this afternoon, so we're going back around 2:30 around here. So any of you want to meet with her, she's going to be between 2:30 and 5 o'clock if you meet her. So we've already some people who signed up. Jennifer, thank you very much, Aki, for this excellent presentation. It's been a pleasure.
Thank you.